There we go. Hey, everybody. I'm Margaret Baltiera. I am your AWS Chicago user group leader. Thanks for joining us virtually. Thanks to the powers of technology, we're able to have our wonderful speaker tonight based in Dallas. So it is the Chicago group, but we get to be more global when we're virtual. So my 2 cents at the beginning, find us on awschicago.com, link to the events, shows the meetup page. Join us. If you're in the meetup, you're a member. So I'm always looking for folks to present, sponsor, host. We're going to start doing a few more things in person, especially as it warms up in Chicago. So if you could host, or if you want to buy the pizzas one time, let me know. Let me stop sharing. That's it. That's my spiel. So it's all you, Damien.
Okay, cool. Thank you so much. Hello, everyone. I'm just going to share my screen and then we'll just get right into it. So let me share and then I'm just going to go play from start since PowerPoint does not like Macs. Okay, so so what I'm going to talk about today is, and this is actually going to be, we're going to go over, it's called a 10,000 foot view on how to create automated data and malware mitigation controls. So a little bit about this background. I mean, I have this project that I've been working on for about a year now, almost about a year, that kind of helps people automate those type of controls using a plethora of AWS services. So let's just go ahead and just get right into it. And I'm going to basically talk you guys through an end-to-end workflow on how to be able to do this. And I'm going to also throw in like explain a scenario that is not targeting any of the companies that we know today. It's just like this make-believe scenario to kind of help you guys understand what exactly we're trying to accomplish and how we can do that. So it's a little bit about me. So who am I? So it's a short bio, but I'm currently a cloud security engineer at Citibank. I am soon to get my master's degree in cybersecurity at the tail end of March 2K23. I am now multi-cloud, so I don't necessarily focus on just AWS. I am now moving into GCP, which I kind of sort of like. So I have 3 AWS certifications and 1 GCP certification and counting, meaning counting on both sides. I do plan on getting my professional AWS cert very soon. I am an open source contributor, so the project I'm going to talk about a little bit is DataCop, which kind of goes into the it helps people create those data controls. And then OPA, Open Policy Agent. I don't know if you guys are familiar with it, but it's pretty much like this. It's similar to HashiCorp Signal in a way where you can create policies that block people or prevent people from creating resources in the cloud, like bad Terraform resources or bad EC2 instances or so on and so forth. It's really, really awesome, and it's all written in Go. I'm a father of two cats, so Luna and Grim, those are my cats right here on the left at the top. And then I am a DevSecOps advocate and mentor, so I mentor people and also advocate for DevSecOps across like all of the various companies. So very good. Now my hobbies, I love video games, I also love anime and cars. Favorite anime is Pokemon, as you can see with the 2 Pokemon at the top left. Play plethora of video games, and that's my Subaru, which is it's like my primary investment in vehicles. So yeah, that's just a little bit about me. What turned into like a little spill, but let's go ahead and jump right into the meat and potatoes of this entire talk. So first thing is, why do we need controls? Why do we need data and malware mitigation controls in the first place? So if you guys have been keeping up with the news and everything that's going on in the infosec world, you'll know that for one thing is S3 buckets have been exposed quite frequently within the past couple of years since AWS released it to the wild so that people can utilize the service. So you have some common attack vectors that we have with S3 buckets. You have data exfiltration, and we have ransomware and malware. Ransomware and malware, they just kind of push it up there and then somehow it ends up compromising an EC2 instance or whatever type of service they're using. Examples of data exfiltration, people typically try to take the personally identifiable information, PII for short, and that is typically like your social security numbers, first name, last name, things that identify you as a human being or as a person. Same thing is that you also have credentials and tokens that have also been stolen. And if you take a look at the top right, you'll see that that's actually a Netflix S3 bucket that was breached a while back that had all kinds of great information about their their SQL databases that were spun up in the cloud with tokens, information, and all kinds of stuff. So and the reason why it was exposed because their bucket was public. But neither here nor there. The point is that those are the type of things that happen in AWS. And ransomware and malware. It really kind of depends on the intent of the app itself, but the impact in itself may vary. So if let's say like if someone uploads a malware application, a malicious application that when your EC2 instance, it's say if it's reading or writing from the S3 bucket and it takes that in and it executes it, that malware, you don't necessarily know what type of intent it has. So it could be to just act as a backdoor. It can open a backdoor, mess with some of your configurations on your machine. It can break your application. We don't necessarily know what exactly is going on. So that's essentially where we're at there. And then some causes behind these attacks, right? When people are attacking these S3 buckets is that step one is misconfiguration. So misconfiguration is one of the top things with S3. And the reason why is because um, misconfiguration, S3 buckets typically have, a lot of people don't know about the security features of the S3 buckets, and they're not necessarily enabled by default. Well, as of late, they are. But before then, when they disabled public access, a lot of people didn't know much about S3 buckets being publicly accessible. They also didn't know that there are monitoring solutions out for S3 and how to kind of tightly couple those into those S3 buckets. And there's also a lack of access control. Lack of access control, meaning that sometimes people aren't familiar with bucket policies and how you can restrict certain users and roles from having access to it. So lack of access control and also a lack of monitoring leads to misconfiguration, really. So it's all really bundled underneath misconfiguration, but lack of access control and lack of monitoring really is one of the two major things for why we would need controls for S3 purposes. So I'm going to start us off with this scenario. And this scenario is going to help us shape this picture of how we should be able to insert controls into certain areas to prevent things in the future. So I created this make-believe company called Genericx, but it's basically a mid-sized mobile gaming company that caches server and user data within several S3 buckets and on-premise, right? So you got a little bit of cloud connectivity and a little bit of on-prem connectivity. The company typically operates out of a single AWS account and utilizes a plethora of services such as you got EC2, Lambda, and code build, and code commit. So they released this hit mobile game and they sold over 1,000 copies of Angry Dolphins, which is their hit mobile game. So shortly after that debut, the organization was hacked, right? And what ended up happening was the hackers gained access to the EC2 instance that was storing and retrieving, PII and PCI data. So PCI data is essentially like your credit card data from a single S3 bucket, which was public, right? Now, I don't know how that happened, but based on that report, a recent report from CloudOne, which is a Trend Micro solution, the S3 bucket contained a malicious Excel workbook that was loaded onto the web server. So that workbook could have had the things that the customers were storing, such as that PII and PCI, and created a backdoor for hackers to SSH into that instance, right? So a lot of things happen there, but the key things that I want you to really look at is that they were, number one, they were hacked. And then the hackers were able to gain access to the EC2 instance that was storing and retrieving the sensitive data from a single S3 bucket. And that S3 bucket in itself contained a malicious workbook, right? Excel workbook. So let's look at the architecture, because a picture to me means it can, say 1,000 words, right? So the first thing is that when you look at the bad actor, you'll see that that bad actor, he's the hacker or she's the hacker or it, they. So what happens is that the customer ends up uploading their report, right? Or they ended up uploading that report to that PCI, PII data or the S3 bucket right there. And you can see that it's actually unlocked. So what ended up happening was that payment processing EC2 instance ends up, reading from that S3 bucket and copying data on there and executing it. And then you can see that with every EC2 instance, in order for them to be able to access the S3 bucket, you need to have permissions or access to it, which means that you'll need a service role. So you'll see that we have an EC2 to S3 service role there, right? So that's essentially how that worked. Now, how the bad actor got into the S3 bucket or was able to upload, publish data to the S3 bucket is the reason why, it's because it was unlocked. So that's actually one thing that we really need to pay attention to. And in order for us to be able to kind of mitigate those things, this is where this service called Macie comes in. So AWS Macie, I love to death, but it's basically a data security and privacy service that leverages machine learning and pattern matching to discover the sensitive data you have in AWS, specifically AWS S3. So the beautiful thing about this service is that it automatically provides an inventory list of S3 buckets and classifies them and everything in it, all of their objects. And it also can help those organizations meet those data compliance regulations, not just for, the United States, but also internationally. So they have support for GDPR and also HIPAA, FedRAMP, you name it, they have it. So with Macie, what ends up happening, some of the pros and cons of Macie is that they have fully managed sensitive data types. So Macie's fully managed sensitive data types essentially are regular expressions that they support that you can use to kind of parse through those files. So if you take a look at the picture on the right, you can see that we have social security numbers, taxpayer identification numbers, social insurance numbers, so on and so forth. And then the best thing about it is that they have sensitive data types for literally every country in the world. So it just makes it so much easier to leverage. There's some for United States, there's some from China, Japan, you name the country, they will most likely have it. And it's also seamless. It provides seamless integration with all of the other AWS services. So like if you leverage like step functions, CloudWatch, EventBridge, it basically you can integrate Macie into any of those services very, very easily. Um, if you have an organization that you have specific special data types that you want to catch and classify, you can also do that as well with Macie, because you can customize it and add in your own data types and fields for your risk and data classification. And you can also create an automated sensitive data discovery job that can run on a specific basis. Or now what they recently released this, like right after reInvent, but you can now enable Macie to automatically discover your data regardless. So the job, when you upload something to S3, it'll automatically trigger the job without you necessarily having to do it to yourself. So it's amazing, like super duper amazing. The bad news is that, of course, it's very expensive. So when you have a lot of, like machine learning and AI in the background, NLP, really natural language processing capabilities, it's going to cost you. So it's super expensive to use. The next thing is that, let's say if you're a developer or somebody and you're attempting to do this via the code or coding it out, when you get the results, it can return a very bloated JSON file. And sometimes that JSON file can contain like over 100,000 to about 1 million records in just one for a single job. And the bad thing is, just to add injury to it. There is no feature available for auto remediation of buckets. So they'll tell you something's wrong, and they'll say what type of data that you have, and if it's a high risk, they'll say that and like highlight it in big bold red letters, but they won't do anything about it, right? So it's totally up to you to be able to do something about it. That's the biggest con of Macie. So then we have another solution that you can incorporate or we can use, and it's called file storage security, and it's produced by Trend Micro, CloudOne. Now I'm a Trend Micro fanboy, and their solution, CloudOne, is so nice. Um, I can't really say much about it aside from that. It's super nice. So let's get into it. So cloud native is a cloud native security solution for S3 buckets and file systems. It also provides anti-malware scanning on files in multiple cloud environments such as AWS, Azure, and GCP. I don't know if they're going to add Oracle Cloud, but that's probably a story for another day. It detects several types of malware. So you have, and the top three I picked were Trojan, ransomware, spyware, but they detect so much more than just those. And they support the scanning of several different like file types. So let's say if you have a bin file, an executable file, CSV, a PDF, they have a long list of the different file types that they're able to parse through and scan and determine whether or not this file is malicious or it's not malicious. So that's pretty much file storage security in the nutshell. And let's really dive into the architecture of file storage security and see what it really looks like. So this is pretty much an architecture diagram of file storage security and how it works. So let's say the user has a file and it triggers this job. What's going to happen is that that file is going to be uploaded to their cloud storage containers. And within their cloud storage containers, somewhere in a mystical or mysterious account, their scanner that they've written is going to be triggered automatically. And the beautiful thing about that is that scanner is going to be triggered. It's going to scan and parse through that file and all the binary code that is made up of that file. And depending on the customization that you've put into it and any kind of plugins that you have, it's basically going to let you know whether or not the file in itself is vulnerable or not. And it's going to tell you that. And it's going to also classify the type of malware that it could possibly be, whether it be a Trojan or ransomware, spyware, so on and so forth. So it's going to do all of that in that account, and then it's going to send it straight back to you. And it's going to, which is connect with downstream workflow, which is it could be sending you an email, text message, or Slack message, right? There's so many different plugins that you can incorporate into this to make it easy for you to be able to use. So let's get into the pros and cons of file storage security. So the pros, so if you have big files, like 10 gig, 20 gig, it supports the scanning of those massive files and it's extremely fast. So you can it, estimate between maybe 3 to 25 seconds on in order for you to be able to get a response on what kind of file it is. And that's including like those massive files, like those 3 gig, those, those 5 gig, those 10 gig. So it's very, very fast. It's also capable of scanning multiple files at a time and returning you that information. So it's concurrent. And it's super easy to deploy and it's very extensible, which we're going to talk about when we go over everything later. The con that we have is that it's not free. That's the only con that I could come up with. It's not free. So you have to subscribe to it in AWS, which is good, and you have to pay for it. And you pay per use. So that's also very good, but it is not free, unfortunately. So
Is it like
now
Macie
that
expensive
we've
or
kind of
is it
covered the two
more
main
reasonable?
components. Mhm.
Oh, sorry. Is it Macie expensive or is it like how expensive?
Um,
Not free, is it?
so it's hard to say because from what I know, Macie has a price tag attached to it, and it can tell you like they have a metric, right? It's like, okay, for this amount of for this amount of gigs that you scan every month, like I think it's like maybe 1 gig is free and then the rest is like 10 cent, right, per gig that you scan. With file store security, I'm not entirely sure how they price, what the pricing is. So
Totally
that's
fine.
something
I
that
was
I
just
would have to
curious if it
research.
was
Oh,
outrageous or more
I'm, s-
limited.
I'm sorry, you were kind of cutting out.
I was just curious if it was outrageously expensive or cheap, but
Um,
you don't have to know. You don't have to tell me.
yeah, I really don't know, to be honest with you.
I
That's
can
that's a
Google
question
it
I have
too.
to take back. Yeah, yeah, I have to take that one back and see. But I can already tell you it may be just probably about neck and neck to Macie. And the reason why is because the majority of the scanning happens on their end in their AWS account. So I think it really is just like you may pay a flat price until you go over a certain threshold. Yeah, but I'm not entirely sure on that part. But if we step back into the Genericx architecture and findings, so let's say, for example, the security engineer for a Genericx company, they realize that they got breached. Oh no, they have to do something about it. So what happens is that after the breach, they recovered from it. They go back and they start to tighten up their infrastructure, right? So the first thing is that the engineer is going to log into the web console and they're going to execute a Macie job. And what that Macie job was able to find is, for example, it was able to find well over 4,400 credit card numbers and 50,000 social security numbers. Uh, and this is from the data that was once, let's say, this is the data that people use to be able to buy their hit mobile game, you know, but they had to supply their social security number for whatever reason. So Macie was able to kind of classify that information and determine the risk of that information. And since there's social security numbers and financial information, they're by default, Macie is configured to classify that as high. You can change it, but they're going to classify that as high. So let's talk about the next thing, which is the scenario. Let's say if we incorporated file store security into this. So they finally understand that, hey, we probably need to also scan this bucket for malware because we see that there's this file in here that seems to be pretty malicious, but we don't know. So the first thing they're going to do is they're going to log into the Trend Micro console, which it comes with their own console where you can kind of look and see their own dashboard. You can look and see the malware and stuff like that that's tied to that account. And once you do that, is going to they can since it's tied to their account, which is their Trend Micro account, the only thing that it's going to do is that your account's going to pretty much be subscribed to that account, right? And what ends up happening is that the third thing is that Trend Micro has their own infrastructure that deploys straight into their account, into your account, and then you can execute that um, though that step function or whatever it is um, on the S3 bucket, right? So that's essentially what's going to happen. And you can see that the S3 bucket is still unlocked, which is unfortunate, but that's essentially what it is. So we know that the majority of this right now is handled as all manual, assuming there's no automation in all of this, right? So the bad thing about it is like manual mitigation, right? A mitigation strategy without automation in Kila in a place like this or a phase like this is not good. So the thing is that, and we'll kind of go over these mitigation steps without the automation. So the first thing that the incident responder, security engineer, or whomever is responding to this has to do is they got to attach an S3 bucket that denies all the access to the resources and services for one to kind of contain that. Then they have to go through and inspect each object and file and identify what the issue could possibly be. So if it has PII, PCI, then you probably need to move it on-prem or to the file server. And if not, then you figure out whether or not it's malicious or genuine. So it's a bunch of if this, if that. You don't know how long it's really going to take, right? But you have to know you have to act on it. So that's where this awesome tool called DataCop really comes in, and it kind of helps tie that piece together. So this is where we get into DataCop. So it's basically this open source AWS framework that mitigates the potential of those vulnerable S3 buckets. So it leverages the results from Macie to automatically block those S3 buckets that contain that PII and any classified information. So some of those features is that it automatically provisions the infrastructure to bridge the gap between Macie and S3 using AWS's Cloud Development Kit and Python. It also has configurable settings for bucket blocking, and then it also has event-driven bucket blocking as well. So all of that's tied into the Event Bridge. And if you wanted to extend it to meet or incorporate some of the other AWS security frameworks, you can also do that as well. So how does this really tie into, um, you know, Macie and file storage security? We'll talk about that in just a second, but let's go over the considerations, right? So some things we got to be mindful about with this is that if you were to use it and how to use it, um, there are a lot of IAM permissions and policies that must be created for the following services to be utilized. So with IAM, we're going to need Event Bridge for, those event-driven messages to get, to trigger things in AWS, Lambda. We're also going to need CloudWatch for logging, SNS for sending out those emails to notify everyone that, hey, everything's been mitigated. Don't worry about it. A step function so that we can see like how things have been mitigated. And then also S3, which is going to be mostly for us to be able to pull those files, right? So the beautiful thing is that when you have this and you have this infrastructure that you're trying to create utilizing these services, DataCop already does that for you. So it creates the needed roles and permissions for all the services, and it won't even modify any of SCPs that you have. Like, let's say, if, for instance, your organization has designed their SCPs in such a way where you as an employee, you cannot create EC2 instances. It won't modify that at all. Or you can't create a step function. It won't modify it at all. It'll adhere by the SCP. And then also for quarantining like malicious files and stuff like that, and a new S3 bucket will be created. So let's get into the DataCop and Macie architecture preview. So this is just for Macie in itself. So I'm a security engineer and I found this amazing like framework to kind of help tie the pieces together, right? That I wanted to use. So I'm going to log into the console and I've pretty much already deployed this, and I'm going to trigger the Macie job on that S3 bucket one more time. Since DataCop is already subscribed to that S3 bucket, what do you guys think it'll do? And that's a rhetorical question because I want to explain it. So this is the walkthrough in which we have this exploded architecture diagram of what exactly Macie is going to do. DataCop is going to do, I'm sorry. So the job is going to be executed on that S3 bucket. The results from Macie are going to be sent to a result logs bucket that's created by Macie. And then DataCop, the event bridge service or the event bridge rule that we've written for it, will look at the result logs and it will pull that information from there and then incorporate that into the step function and pass that from the step function. It's going to execute it and pass those logs to the Lambda function, right? And that Lambda function is going to be executed a series of times. And that step function is going to continue to execute through a series of steps. And once it's done, it's going to send an email through SNS to whoever is subscribed to it, right? And I'll show you guys what that looks like in just a second. But that step function is the most important thing. So with the Macie, the DataCop Macie State Machine, right? This is a step function and what it looks like visually. So there's a total of 1, 2, 3, 4, 5, 6, 7 key states in the step function. But the ones that I really want to hit on are determine severity, check bucket status, block S3 bucket, and then descending of the reports. So the first step is determine severity. So when this step function is executed and the file is uploaded from Macie, it's going to parse through that bloated JSON file with millions and millions of records. Well, hopefully not millions, but lots of records, and it's going to determine the severity for a particular S3 bucket, irregardless. And it's going to check the status of the bucket, meaning if it's already been blocked or not. And if it hasn't been blocked, right, then it's basically going to block that S3 bucket by creating this deny all policy that will deny everybody access, including people within the organization, except for people who are subscribed to a specific role. And that is configurable in the project, but it's going to deny everyone access to the bucket, including public access as well. So, and once it's done, it's going to send a report or send an email saying, hey, this bucket was blocked. And this is the reason why I was blocked, and keep moving, right? And that's just with Macie. So you're probably wondering, what does that look like with file storage security? Because Macie takes care of the personal and sensitive information, but file storage security might not, right? Well, let's look at the architecture of file storage security. So remember at the very beginning, we had the bad actor or the threat actor submit this, or not submit, but upload this malicious Excel workbook to this S3 bucket. So the first thing is that Trend Micro, since it's subscribed to that bucket, or since their structure is subscribed to that bucket using EventBridge, what do you think is going to happen when that information is sent to DataCop, right? And you see there they have an account somewhere, and I keep this mystical account here with the 3 question marks because it's very important, because that's where all the magic happens on their end. So this is what that will ultimately look like exploded. So let's say, and I can rename the report TPX reports. So that threat actor submits that, or it's not submits, but uploads that malicious Excel workbook to that S3 bucket. And what ends up happening is that Trend Micro has a Lambda function that basically takes that file and uploads it to their malware repository inside of their other account. And that's where they perform the scanning. And those scan results are then going to be sent right back to that Lambda function, and is then going to trigger the DataCop Lambda function to be able to execute the step function, right? The FSS step function. And then from there, it's going to go through a series of steps. And once it's done containing or blocking that S3 bucket, because it has, those malicious files in it, it'll go ahead and it will send a nice little pretty report saying that, hey, we blocked this S3 bucket and we're good to go, right? And we've also quarantined these objects. So this TPX reports would also show up in that email as well, which is also nice. So let's talk about that state machine, right? Because it's the most important, one of the most important things, because it ties everything together. So this state machine has a total of 8 states within one step function, but there are 5 key states that I really want to kind of cover. So the first thing is that when it starts and we get that information back from Trend Micro, is going to copy the object to another bucket called the quarantine bucket. And it's going to then remove that object from the parent bucket that it was uploaded to. So that quarantine bucket is pretty much like isolated somewhere, where the security engineers or whoever the InfoSec people are, they can reach into that and perform like some analysis on what type of file that is. And once it's done, it'll block that bucket and also send a report out and let people know, hey, this object was removed and this bucket is now blocked. So you don't need to worry about that at all, right? So that's essentially how it all kind of ties together with file storage security and DataCop. So when we look at the big picture and how everything really looks, this is what it'll look like from a DataCop perspective. So you see we have both Macie and Trend Micro's infrastructure, and DataCop sits smack dab in the middle. So the security engineer executes a Macie job, and DataCop will pull the result logs from their Macie result logs bucket. And then it's also going to get triggered again by Trend Micro, the Trend Micro's infrastructure, because it was able to find, hey, we found a malicious, file within this bucket. So let's go ahead and let's do something about that. So you see hit from both sides. and you move on over into the second step, which is where DataCop will reach in and it will perform those activities like blocking that S3 bucket and then also copying those TPX reports from the PII data bucket into the quarantine bucket. It'll also lock that bucket so that it no longer has public access. And then once it's done, it'll send that nice little report, which you see down there. It says success, DataCop S3 bucket blocking. And it will tell you how many buckets have been blocked. And it'll also give you the information on the step function logs with the execution ID. So you can kind of keep track of everything that's going on right now. So that's in a nutshell, an overview of how you can kind of go in and utilize this platform to be able to uh, create these type of controls to help protect your environment from data exfiltration attacks and malware attacks, right? By having these automated incident response capabilities included into your overall AWS architecture, really. So some of the benefits of creating these controls using Macie, DataCop, and file storage security. So one can expect to minimize at least 2 attack vectors in AWS. There are multiple more, plenty more that I'm very aware of, but the 2 main ones that I want to talk about and I want you guys to know is data exfiltration, and you have also ransomware and malware attacks are pretty much minimized completely. If by any chance there is any kind of malicious files that enter your S3 bucket by any means, you get a quick response time to any of those malicious files. So you don't necessarily have to sit there and do everything manually. Since it's all automated, it may take what may take you a week to do. It could take only a couple of seconds or a couple of minutes. Um, it's also a completely scalable framework that can be deployed into multiple accounts. I know several different organizations nowadays have tons of AWS accounts. So this is something that, can be deployed into multiple accounts, and you can also deploy it into your own account and then test everything out personally if you want to. And you also save a ton of hours on manual labor and analysis by eliminating the complexity of those tasks for blocking S3 buckets, such as you are um, creating your bucket policies, and you're inspecting each file, and you're triggering it's all the clicking. It stops, it ceases when you automate all these things. So you want to make sure that you're creating controls and you're automating them. And this is one way of doing it. Although there are a plethora of ways, this is one way of doing it. And with that, I would definitely like to kind of end my talk. But I'm more than happy to like go through some code with y'all if y'all want. But thank you very much for listening to me ramble a little bit about how to create data and malware mitigation controls.
I see lots of
And
little
I'll open the floor
emoji
for
clapping.
questions. Yes. Thank you guys. I really appreciate it.